The last goal on this particular day, or this first day of Chapter 5, is to learn how to differentiate the natural log functions. Quick review, differentiate, I think that has something to do with taking a derivative. So we're going to jump to problems number 6, 7, and 8, and we're going to now try to take the derivative of a natural log. Well, the derivative of natural logs is going to be one of your favorites. It's kind of a nice thing to have to deal with. So here we have the derivative with respect to x of the natural log of u, and then let's make a quick note right here that u is a function of x. Okay, just so that we know that. So u is a function of x. So if that's the case, and I go to take this derivative very simply, the derivative of natural log of u, 1 over what you are taking the log of, times the derivative of with respect to x of what you were taking the log of. So 1 over u times du over dx. So logs are really kind of nice. We go to take that derivative, 1 over what I'm taking the log of times the derivative of what I'm taking the log of. So looking at problem 6, looks like we have 2x going on right there that we're taking the log of. So this derivative, 1 over 2x times the derivative of 2x, which is 2. Clean it up. There's my derivative. Kind of a nice one, not too bad. Number 7 then, let's see, so if I want to take the derivative of this thing, well, treat it the same way. So we've got natural log, we're going to take the derivative of this thing, so 1 over what I was taking the log of times the derivative of what I was taking the log of. So let's see, so that'd be 1/2 quantity x squared plus 1 to the negative 1/2 times the derivative of the inside, which is 2x. So I did derivative of a log. So what I really have is I have x squared plus 1 inside a square root inside natural log. So I had to do 3 pieces to my chain rule. So now if we go to clean this up, let's see. So I have 1 over my square root of x squared, 1 over my square root of x squared plus 1 times x over my square root of x squared plus 1. Let's see, so if I clean that up, how about x over, multiply 2 roots together that are identical, x squared plus 1. So there's my derivative. Now, I'm a big fan of trying to make these problems as easy as I can on myself. So you've seen the red way to do problems like these. So if I look at number 7, one of the things I could have done with this problem before I started is I could have rewritten what was inside the log, and what I see inside that log is I could have said, hey, you know what, that x squared plus 1 is being raised to the power of 1/2. What if we made that 1/2 be a coefficient, and then we took the log? Might make things a little bit easier. So if I did that, let's call this the blue way to do this problem. Well, let's see that derivative. Well, 1/2 is a constant. It's along for the ride. Derivative of natural log is 1 over x squared plus 1 times the derivative of that x squared plus 1, which is a 2x. Clean all that up. We end up exactly where we were before. So the reason that we want to go through and do these log rules is because a lot of times they're going to make what we're doing a heck of a lot easier on us. So we want to kind of see what we can do to make things easy. Because when I look at a problem like number 8, I am not even going to try. I can't wait to see somebody start this problem off by going, okay, well, let's see, 1 over, oh man, don't even get into that. That's just going to make things hurt. What we want to do with this thing instead is let's use our log rules to make things easier on ourselves. So let's see, I've got, in the numerator, there's 2 things being multiplied, so let's rewrite that. Natural log of x times, so I've got multiplication, so let's split it into addition. And then I've got natural log of an x squared plus 1. And that x squared plus 1 was being raised to a power of 2. Let's make that 2 a coefficient. And in my denominator, I have a third log, again, because we'd have to eventually turn it into subtraction, natural log of 2x cubed minus 1. And that would have a 1/2 power on it. But let's make that have its own exponent, or its own coefficient of a 1/2. So what we've done now is we've turned this one derivative, which was kind of nasty, into 3 derivatives, which are going to be a lot easier. So if I go to now take my derivative, well, let's follow my derivative rule. So my derivative rules, let's see, derivative of natural log of x is 1 over x times 1. Plus, I've got a 2 along for the ride times the derivative of 1 over, or natural log of x squared plus 1, 1 over x squared plus 1, times the derivative of x squared plus 1, which is 2x, minus, there's a 1/2 that's along for the ride, times the derivative of natural log of 2x cubed minus 1, which would be 1 over 2x cubed minus 1, times the derivative of 2x cubed, which would be 3x squared. So there, that red thing, whoops, I guess I need this bracket. That red thing would be my derivative. Now it's up to me to simplify. It looks like I'm going to have 3 terms. So if I start cleaning them up, here's a 1 over x plus, looks like I have a 4x over x squared plus 1 minus, how about a 3x squared over 2 times the quantity 2x cubed minus 1. Now, yes, we could get a common denominator. Yes, we could put that together. Will we be expected to do so? I'd like to think that at this point in your life in calculus, you would be able to find that common denominator, but really the new thing for us right now is being able to play around and find these derivatives, and hopefully we don't have to do anything so nasty as find that common denominator, and if we do, hopefully they'll have mercy on us and not ask us to do too much more. So we're going to stop there with derivatives. Long story short, derivative of a natural log, 1 over what I'm taking the derivative of, or 1 over what I'm taking the log of, times the derivative of what I'm taking the log of. And it looks like I erased part of my word function. So